All right, so in Google Classroom, we are in week 22. Does anyone know how many weeks of school there are? Nobody knows? 40. Yeah, there's 40 weeks. So we're more than halfway, So you can open up today's Nearpod. Notice now that I've added an extra link here. So if you happen to be absent today, you would click this link here to complete it at home. That way you're able to go through the slides, okay? If you click this at home, you won't be able to do anything with it. So if you're absent or you're working virtually that day, then you want to make sure that you use that link. That's not how I want to get in though. I won't be able to change anything. So our next unit is chemical reactions. And today we're just going to get a brief introduction to the unit, figure out what our problem is that we're trying to solve, and look at some different substances, make some detailed observations. All right, here we are. Anyone need help getting here? All right, hopefully your screens are changing. Yes? Oh, I was successful. All right, so today we're going to begin this new unit called chemical reactions. And in this unit, you're going to be investigating a problem that a town is having with the water coming into their homes. Let's start by thinking about the importance of clean water. For a moment, 30 seconds, no hands up. I want you to think about how would your life be different if you did not have access to clean water. Okay, now right now you have access to clean water for drinking, doing dishes, showering, feeding your animals. Think of all the things you use clean water for. How would your life be different if you didn't have that access? About 10 seconds for thinking. What do you think? Who would like to share? How would your life be different? Nathan?
You probably have to boil the water before you want to use it.
Yeah, you might have to boil it every time you wanted to use water. So then what if you're thirsty? You got to boil it and then what?
And then you would have to cool it off.
You'd have to cool it off, right? So you'd have to let it cool down. If you put ice cubes in it, then that means you had to make those ice cubes, right? So that process, doing the dishes, showering, you would have to boil water. How else would your life be different? Yeah, you might get sick more often, right? Because if your water's not clean, you could be drinking certain bacterias and pathogens that your body isn't used to having, right? Digestive issues, parasites, those types of things. Anything else? I heard wash your clothes. You got sliders, I came towards you. Wash your clothes what? Yeah, right? If you're washing your clothes with dirty water, is that going to help? Not really, right? So your clothes aren't going to be as fresh as you're used to having. So there's lots of impacts that we don't really think about, but water has a huge part of our lives, not just for drinking because we know it's essential, but for cooking and cleaning and bathing and all of those other things we use water for. So the water we use in our homes must be treated before it is safe to drink. So there's water treatment centers, or if you work out of a well, it's actually being filtered through the ground. And then you may also have a water treatment apparatus in your basement or somewhere in your home. Scientists work every day to ensure that our water is safe. You're going to watch a video about a scientist who uses chemistry to help keep water clean and safe to use at home. So we're going to watch this chick. She is a scientist, a chemist.
Most people don't think about where their water comes from when they turn on a tap. But there are a lot of people doing hard work to make sure that water is always available and always safe to drink. My name is Christy Lawrenson, and I'm a senior chemist with the East Bay Municipal Utility District in California. We provide clean, safe drinking water to 1.4 million people every day. Water has some substances in it that can be seen, tasted, or smelled, and others that cannot. Some of these substances are unsafe, while some are there to protect us. The government sets laws about which substances are allowed and which ones are not. As a chemist, I studied the properties of substances. I use this knowledge to test our water to make sure it's safe. A lot of work goes into keeping the water safe. Every day, water system inspectors collect samples from the different reservoirs, water treatment plants, and the distribution pipes that serve the community. And every day, our lab runs tests on these samples. Laboratory, this is Christy. You have a drinking water sample? Okay, so I will meet you in sample receiving. When I receive a sample delivery from the field, I usually make a visual observation of the sample and then schedule it for testing. You got some samples there?
I do indeed. I called you about them this morning,
Okay.
and I just wanted to bring them in for you.
So, this looks really clear. Is this drinking water?
Yes.
Okay, so why don't you fill out this paperwork for me?
Okay.
So we'll run the tests and I should have results for you in about 2 days.
Perfect.
Just because a sample of water looks clear or has no smell doesn't mean that it's safe to drink. We need more supporting information to make that conclusion. That's where lab testing comes in. This is our lab, and this is where we test water samples. One of the tests we do is for combined ammonia and chlorine. Chlorine and ammonia are substances that are added to the water to prevent bacterial growth. This test will allow me to gather information to determine how much combined chlorine and ammonia are in each sample. And a green color will develop if combined chlorine and ammonia are present. Now I wait and I observe to see if a green color develops. Now I can use my observations to determine how much combined chlorine and ammonia is in the samples. The public puts their trust in us every time they take a drink, wash their hands, or take a shower. We take that responsibility very seriously. We test our water 365 days a year, and we provide that information to the public. I'm proud to be part of keeping my family, my friends, and my community safe.
Alrighty. So we're going to be working to investigate the water in a town called Westfield. Oh my gosh, that just reminded me of something. Has anybody, total tangent, has anybody watched WandaVision?
No, because we don't have Disney Plus.
Oh, and it happens in Westfield, and so that's why I just remembered. Sorry. All right, so the message, it's a very good show if you get a chance. The message on the next slide describes the problem. Although this scenario is fictional, the chemists, like the one in the video, often work to ensure that the water is safe to drink. Okay, so this is really small. I will read it to you if you're able to follow along on yours. So 2 student chemists from Dr. Samara Young, she's the lead chemist, and the subject is the water crisis in Westfield. Last week, I received a call from Alexa Anderson, a resident of Westfield. When she turned on her faucet for a glass of water, a strange reddish-brown substance came out. She called a few of her neighbors and found out that the reddish-brown substance was coming out of their water pipes too. My lab uses chemistry to identify unknown substances, so I went to Westfield to take some samples. I took a sample of the water coming out of the pipes and another sample from the well where the neighborhood's water comes from. I analyzed the samples and made an interesting discovery. The water coming out of the pipes contains the mysterious reddish-brown substance, but I didn't find any of the reddish-brown substance in the water sample that I took from the well. Instead, I found something else. It appears that some fertilizer from a nearby farm seeped into the well water. We need to do more analysis in order to identify the reddish-brown substance, but my lab is unfortunately busy with other projects right now. Therefore, I need your help to get to the bottom of this mystery. The residents of Westfield need answers. So we are trying to figure out what is in the water of the town of Westfield. The water coming out of the pipes has this reddish brown color. The water from the source, which the well does not, it's clear, but after doing some testing, they found that it does contain fertilizer from the farms surrounding. So the residents of Westfield found this reddish brown substance coming out of their pipes. Water from the well did not have the reddish brown substance, but it did contain fertilizer from a nearby farm. Dr. Young took a sample of water from the Westfield's well. She did not find the reddish brown substance in the sample. However, she did find some fertilizer. So here's the well. There's a picture showing a nearby farm. There's probably more than one. And so in this well, we found fertilizer, but no red. There's a pump that pumps that water through these pipes to the homes of Westfield. And when it comes out of their faucets, it's this reddish brown color. So here are the samples from the well and from the pipes. Notice that the water from the pipes has the reddish brown substance, but the water from the well does not. So I have the two samples as well. The clear one is the well water, and the red one is what is coming out of their pipes. Could you imagine this substance coming out of your pipes? I will say I've had a very similar experience here with my sinks. One year I came in after the summer, and only when I used the hot water, the water was this terrible, terrible brown color. Like it was disgustingly brown. Even sometimes it still is. So it's interesting that it happens, but there are reasons, and so that's what we're going to be figuring out throughout this chapter unit. Remember that even though the water taken from the well appears clean, as you saw, it looked clear, Dr. Young actually found a fertilizer in the sample. So while we are focusing on the mysterious substance in Westfield's water supply, we're also answering a more general question in this unit about how substances form. So how did that reddish brown substance form? That is our unit question. First, you're going to be working to help Dr. Young identify this reddish brown substance in the water for the people of Westfield. So chapter 1, what is that reddish brown stuff in the water? That's what the first chapter will focus on. These are the claims that we're going to be considering. The claims deal with 3 key substances: the mysterious reddish brown substance, the fertilizer, and the substance that makes up the pipes. Because you might be thinking, well, it's just the stuff coming out of the pipes into the water. So we're going to be looking at that as well. So by conducting investigations and gathering evidence, you will use chemistry to help solve this mystery. The first claim, the reddish brown substance, is the same as the substance that makes up the pipes. So when they turn on the water, whatever that pipe is made of, it's mixing with the water, and that's what's coming out of the faucet. That's our first claim. The second claim is that it's the same substance as the fertilizer. So whatever that fertilizer is, it's coming out into the sink that color, the reddish brown color. And the reddish brown substance is not the same as either one of those things. It has nothing to do with the fertilizer. It has nothing to do with the pipes. The word substance appears in the chapter 1 question and in each of the claims. You will learn more about substances throughout the unit. For now, think of a substance as a type of material, such as plastic or water. So a substance can be anything. Observing substances is an important first step for chemists who are trying to identify an unknown substance. A 7th grade student named Jun observed examples of the reddish brown substance, the fertilizer, and the substance that makes up the pipes. We do have what she said about these, but I also want you to have them as well. I think it makes it a little bit more real for you. In order to do that, we need to obviously use our precautions. So what we're going to do is hand sanitize, and then you may take a basket. If you prefer not to take a basket, that is fine. You don't want to use hand sanitizer, whatever that may be. You're lucky enough that no one has touched these yet except for me. This is the first period, but I will be disinfecting them between each question. So, Brody, would you like a basket? All right, come on up. Clean your hands and then grab a basket. Come on. You want one? No? You don't want one. Come on. Yep, take a basket. Olivia, you want a basket? Addison, that is perfectly fine. There'll be videos and pictures and things for you to look at and participate as well. You want a basket? Yeah. Okay. So either make some room for it on your desk, you can take the samples out and put those on your desk, however you want to do it is fine. No rules. So the first thing that we're going to be looking at are the three jars that are labeled pipe substance, reddish brown, and fertilizer. So in the basket, they're kind of separated into a group of 3 and a group of 4. We're looking at the group of 3. So the first one we're looking at is the pipe substance, okay? And this sample was taken from the water pipes used in Westfield. So this is the stuff from the pipes. The pipe has been broken to make it easier to examine the substance. So if you go ahead and take a look at that substance or the picture of the substance, John observed that the substance is gray and made of small, hard pieces. The pieces are a little bit shiny. Is there anything anybody would like to add to her observation? I think it's a pretty detailed, quality observation. So that's the water pipe. The next is the fertilizer, and it is labeled fertilizer, from the well water. The water was evaporated to observe just the solid. So they gathered the water from the well, they let the water evaporate and left behind this white powdery stuff. So her observations, the substance is white and made of small, hard crystals. Again, detailed observation. Questions or additions? The third container is the reddish brown substance. This is a sample of the reddish brown substance found coming out of the water pipes. It was filtered to observe just the solid. So the water, as I showed you, the water that came out of the pipes, they filtered that to leave behind this reddish stuff. And her observation was the substance is reddish brown and made of small pieces, the size of small pebbles. So if you look at it, they're kind of clumped together in there, some of them. So I think that's where she's getting her small pebbles from. Additions or questions about the reddish brown? Mm-hmm.
There's a little bit on the outside. It feels sort of like clay.
Like clay? Okay. All righty. So the observations that Judd made of the 3 substances are called properties. This is our first vocabulary word of the chapter. A property is something that can be observed about a substance, such as its color, smell, or boiling point. Some properties cannot be observed by just looking at the substance. So the observations that we made are things that we saw with our eyes or that Jen saw with her eyes. So there are other properties that go beyond what we see with our eyes. Chemists rely on some properties that can only be observed under special conditions, such as melting and boiling points. Different substances have different melting and boiling points. Therefore, these properties could be used to help identify a substance. So water always boils at the same temperature. It always melts at the same temperature. That temperature at which it does that, or freezes, right? Freezes at 32 degrees Fahrenheit. That is the boiling point, the melting point. And it's always the same for water. It's always the same for a substance. So you can use that to help you to identify something. The melting point is the temperature at which a solid will begin to melt and turn to a liquid. So the point at which those molecules have a little bit more freedom of movement. Chemists can observe the melting point by heating a solid substance and measuring the temperature at which it changes from a solid to a liquid. The boiling point is the temperature at which the liquid will begin to boil and turn to a gas. For water, that's 100 degrees Celsius. Chemists can observe the boiling point by heating a liquid substance and measuring the temperature at which it changes from the liquid to a gas. So the point at which that freedom of movement increases. So let's think about chapter 1. claims that we're considering, and do any of the observations support any of these claims? So take a look at your claims. Claim 1 was the reddish brown is the same as the substance that makes up the pipes. So take a look at your reddish brown stuff. You think that's the same as the stuff that makes up the pipes? The reddish brown substance is the same as the substance as the fertilizer. So compare the reddish brown to the fertilizer. You think that's the same stuff? Or the reddish brown substance is not the same as either the fertilizer or the substance that makes up the pipes. Anybody have any thoughts? What do you think?
I think claim C, because it doesn't look the same as the pipes or the fertilizer.
Okay, so at this point, Nathan thinks it's 3 because they don't look similar to each other, right? They look like totally different substances, which is probably what most of us think right now. In order to choose between these 3 claims, we need to know how to tell substances apart. By looking at them, we could say, yes, they look differently, but it's a little bit deeper than that. We're going to work to answer this question. How can you tell one substance from another? Next, you're going to observe 4 samples. Hold on, I gotta pause my video because the people at home are doing something different. Okay, so for those of you at home, you are actually going to go to Google Classroom and open up the number 2 for today, which is comparing different substances at home. And you're going to pick 2 different substances from the list that you have at home, record their properties in the table, and answer the question. Be sure to turn in your work when you finish. And making your observations, please try to make sure that you're making them detailed observations. So remember on the slide here, oh, too far. You had a list of guidelines that describe what detailed observations are. And you also can use Jun's observations as a guide to make your own. So in Google Classroom, the number 2 for today, what am I doing? And then you'll want to open up the Google Doc. And so it can be any of these types of substances. Okay, so you can pick any 2 and put the name of the substance there and your detailed observation. Once you finish that, make sure that you turn it in. And then that is the end of today's home lesson. Have a great day.